solving trig equations. So this is the first one where you would have to adjust your range. So we're going to solve sine of 3x plus 60 degrees equals 0.5, and that's for our range between 0 and 360. So the first thing I'm going to do is I'm going to think about my adjusted range. If x lies between 0 and 360, then 3x plus 60 will lie between 60 and 1140 degrees. I'm going to use cast. You might use your curves to get your angles. I know that if I inverse sine 0.5, I'm going to get 30 degrees. So I'm looking at 3x plus 60 being 30 degrees. Well, of course, 30 is outside my range of 3x plus 60. 150, 390, 510, 750, 870 and 1110. So I'm now going to subtract 60 off them all, and then I'm going to divide by 3. Now I could put this into my graphical calculator in graph and check. So I could enter sine of 3x plus 60 as y1. I could enter a half as y2. I could set my x between 0 and 360 and then draw and do the intersection. Right, second thing we've got is a trig proof. So trig proofs are quite common, and if it asks you to prove something, you take one of the sides and manipulate it to look like the other side. If you're in trouble, what you can do is you could manipulate the left side, manipulate the right side, and then show that they are the same. Right, first of all, I'm going to take the left-hand side. So if I take the left-hand side, what I've got is, it's two fractions that I'm going to subtract, and I'm going to need a common denominator. So I get them over a common denominator. I then expand those brackets on the top, and my brackets simplify, and then I combine 1 minus cos squared theta, I know is sine squared theta. Then I've got 2 cos theta sine theta, which of course is 2 cot theta. I've proved it. Right, exact values, exact trig values. So when you have exact trig values, so I'm just trying to do it so that I don't have a shadow. Exact trig values. I'm being told that the angle is obtuse. So if the angle is obtuse, and I'm also told that sine theta is 3/4. So I could use a right angle triangle here, or I could use identities, and it wants you to find the exact values of sec theta and then tan 2 theta. They've got to be exact. So what it doesn't want you to do is inverse sine 3/4 and then find the cos of that angle, and in turn find the sec and tan 2 theta. I'm going to use identities. So I know that cos squared theta is 1 minus sine squared theta, so I substitute that in. I know that sine theta is 3/4, so sine theta all squared is 9/16. So cos squared theta is going to be 7/16. Therefore, cos theta is positive or negative square root of that. Because theta is obtuse, I know the cos of all obtuse angles is minus 7/4. So I'm not finding theta. If the cos of theta is minus 7/4, then the sec of theta is the reciprocal of that. And of course, I've rationalized it. So it's minus 4/7. I'm now going to find tan 2 theta and need to know my identity. So that's 2 tan theta, 1 minus tan theta squared. I know it's tan theta sine over cos. So that's going to be 3/4 divided by my minus √7/4. So that's going to give me 3/√7, which rationalizes 3/7 √7. Tan 2 theta, I then substitute into the identity and then just simplify it as a fraction. So I'm getting minus 3/7. Right. solving equations with identities. So again, you've been asked to solve this, and it's in radians, and your range you're going for pi minus pi, but they can't equal them. So the first thing I've done is I've rewritten the 3 over cos x as 3 sec x. And now I know an identity connects tan squared and sec squared. I can't rewrite sec, but I can rewrite tan squared. Tan squared is sec squared minus 1. So I rewrite that, substitute it in, and I've got quadratic in sec. I'm going to factorise that. I could substitute if I wanted to. You know, I could let u equal sec x, but I've just gone straight for it. So sec is a half. Sorry, sec x is a half, or sec x is minus 2. Now, we find it difficult to visualise sec, cosec and cot, so convert them straight into cos. So I've got cos x equals 2, or cos x equals minus a half. Now, in the past, it's been enough just to say cos x equals 2, no solutions, but we think that you may have to justify that. There's no solutions because cos x lies between 1 and negative 1. So you're going to go with cos x is minus a half. Cos x is minus a half. Your solutions for that range are going to be 2 pi over 3 and minus 2 pi over 3. And then our last question, we would say probably, I would say definitely the most challenging. In the past, you would have been given a massive hint in the first part of the question. So the first part of the question would normally have said is write sine x plus root 3 cos x in the form r sine x plus alpha. But there have been some questions on your practice papers where it hasn't said that. It's expected you to know. So how would you know you had to do that here? Well, you can't rewrite sine x in terms of cos very easily. It would be horrible. It would involve square roots. You know, you can't divide all through by cos and get tan because of that equals 1 there. So you have to make this such a big leap of faith, and you're going to write it using your double angle identity. I know, and I've gone with sine of x plus alpha because that's going to fit. You have got a plus, and it's gonna work for this one because of the way that this expands. I'll show you. R sine of x plus alpha expands to be r sine x cos alpha plus r cos x sine alpha. You're then going to compare your coefficients. The coefficient of sine x, on the left you've got 1, and on the right you've got r cos alpha. Coefficient of cos x, on the left you've got root 3, on the right you've got r sine alpha. So tan alpha is r sine alpha over r cos alpha, which is root 3. And you know that that means that alpha is 60 degrees. We always think that alpha lies between 0 and 90. And r is always the square root of a squared plus b squared. So r is going to be 2. So you've written that sine x plus root 3 cos x as 2 sine, open bracket, x plus 60. And now all you're going to do is you're going to put that equal to 1, divide by 2, adjust your range. If you adjust your range, you've got x plus 60 lying between 420 and 60. Just go back, check that that was the range, and it was. So you're then, you know that the inverse sine of a half is 30. So your x plus 60 is going to be, well, 30 is outside your range, so it's 150, 390. So x is 90, 330.